Welcome, Algebra 1. This is Chapter 4 review. Chapter 4, what is a function? This is Part 1. Essential question is, how can I determine if a set of points form a function? Let's begin. So I kind of reorganized a lot of Chapter 4. I did some of this already during class, but I kind of don't like the order the book does things. So I got the main points of this, and this is going to be a three-part series. And I'm going to have, I think, the first two parts or 3 parts this week, and maybe the last part next week, depending on time. So we kind of talked about these first 2 parts in class. So I don't have a video of this. I'll kind of review a little bit today on some of this, but not really. I've done that in class, and you should know at this point. Today's the focus is kind of on this stuff, and the future videos will be on this one and this one. And that's all of Chapter 4. And this is getting you ready for future stuff and teaching you what a function is and how we really are going to graph here in Algebra 1. So let's begin. What is a function? You might have taken notes on this already, but it's every x value has only one y value. These are both functions, and these are 2 different representations. This is a set of points. So in this case, every x value here, or x values, which is our domain, are 3, 5, and -3, and each of them only have one different y value. So since every x value is different, we know this has got to be a function anyways. And in this point, so every x value, so this is an x of 3, x of -3, and x of 3, and x of 5. These all have 1 point for every x value. So I know both of these are functions. These are functions. Now let's take some other examples. So these 2 are not functions. How do we know these are not functions? Well, in the first case here with these 3 points, I am repeating x values. 2, 1, and 2, 3. So it's the same x value, so 2, but it has 2 different y values. It can have 1 or it can have 3. So an x value can go to 1 or x value can go to 3. That's why we're not a function. It's just because of these 2 points. The other point doesn't matter. If there's 2 points that for the same x value but different y values, it's not a function. On this graph we can tell over here on the right, because this point's fine, but these 2 points are our problems. Because there's 2 different x values. It's at x equals 2, and we plotted a point at 1 and 3. So since there's 2 different values for y when x is 2, this was what makes it not a function. Let's talk more about that. So a vertical line test. This is one way to test with a function if we have the graph of it. So a vertical line test is any vertical line crosses 2 or more points, it's not a function. So any vertical line. So for example, if I look at this first case, I can draw vertical lines like that vertical line. It doesn't cross anything, right? But if I draw a vertical line here, it always crosses once. Vertical lines all aboard. And actually I can just take one vertical line and just drag it around. So see, wherever I move this vertical line, it's always only crosses 1 point. So these are both going to be functions. So I'm write functions. I can take another example over here on the right. This is a different type of graph, but see, it always is only crossing 1 point no matter where I go. It's always only crossing 1 point. Yeah, and it's vertical lines. I don't care about horizontal lines. Yeah, horizontal lines this will cross twice, but that's okay. I only care about vertical lines. So these are functions for these 2. Now let's do a different example. What about these 2 examples? Well, these are not functions. These are not functions. How do I know this? They both don't pass the vertical line test. So I'm going to draw a vertical line here and move this around. So this is okay right here. There's no points. It only crosses once here, here, and here. And it keeps only crossing once. But when you get to this point, it is crossing at 2 different points. It's crossing right here and right here. Since it's crossing 2 points at that where x equals 1, this is not a function. Let's go to the other graph. So basically all these points are definitely not a function because they line up in one straight up and down line. So it actually has 6 points crossing. So this is not a function. We can only have 1 point at a time. So if it's anything more than 1, it's not a function. This is definitely not because all of the points cross at the same vertical line. Now, here's another thing we talked about. Linear functions. And I did a video of this last week. I just kind of explain this again. The points form a line. It's a linear function. How can you tell? Is if I draw a perfectly straight line, it goes through all points. So I'm going to draw this line right here. And notice that line that I drew in red crosses through all those points. So this forms a linear function. Let's take this other example right here. So these are both going to be linear functions. We're going to call these both linears. These are functions. Linear functions. Now I can draw another red line. Notice here, I'll start with this top point and go all the way down. All the points are crossed going this way. So both of these are examples of linear functions, because when you draw a line through all the points, they hit all of the points, and it's a straight line. It has to hit every point. So let's take two examples. These are not linear functions. We call these nonlinear. Nonlinear functions. So for example, in this case, if I can't draw a straight line, because if I try to draw a straight line, it tries to curve back up. So that doesn't work. I know that, hey, it's two straight lines, but that doesn't work. A V shape doesn't work. It has to be one straight line that crosses them all, and that doesn't work. Now in this case, you think, well, all of them except for that one point. It's still not a linear function because of, so on here it was because of those points. Here because of this one point. If one point's off, it's not linear. No, even if it's just 1 point. If it's a million other points from a line, but one's not a line, it's non-linear. Now, take some other examples. These are linear, but one of these is not a function. So this first case over here is a linear function. If it goes straight left and right, that's okay. We can draw a straight left and right line. Now this other one goes up and down. This one here, so we can call this a linear function, because it forms a straight line. This is, now the one on the right, this is linear, but this is not a function. Why? Because it doesn't pass the vertical line test. You still got to pass the vertical line test to call it a function. I'm going to say linear and not function, because it's all the points are on the same vertical line. It's linear but not a function. This one is linear and it's a function, even though it's a straight line across. That's fine. Alright, that's it for the video. No examples except for that.